Hi, so in this lab, we're going to configure some routing. So currently, these routers, router LAN 1, router LAN 2, and Edge, the only networks they know about are those networks which they are directly connected to. Those networks which they have an IP address and subnet mask on that interface. For example, uh, router LAN 1 knows about the 10.10.1.0 network because it has an IP address on that network. Just like computers have an IP address on that network, so they know what network they belong to. However, routers have multiple interfaces, each one on a different network. So this router LAN 1, also has an interface gigabit 01 on the 10.20.1.0 network, so it knows about that network, and on the 10.1.1.0/30 network, so it knows about that network. Matter of fact, if I go into that router, we can do show IP route, if I can type it, and we can see that, yes, it knows about those three directly connected networks. By the way, the C means it's directly connected. And the way it knows about that is because it has an interface on that network. Now, don't get confused by the /32 subnet masks on its local interfaces. That has to do with to make it easier for it to know, or more efficient for it to know when there's a packet that is being sent for itself, such as somebody telnet, SSH, or pinging to the router. But don't worry about that. Don't worry about that. Okay, so let's go ahead and do this first. First thing I want to do is go over here, and we are going to connect these two devices to this switch so that we're able to show that we can eventually access these devices, ping them. So let me go ahead and do that. I'm going to hit the zoom in here a little bit. All right. So I'm going to bring up my toolbars, my bottom toolbar, and we are going to connect a cable to the switch. Let's make it fast Ethernet 1. So you can see spanning tree running. That'll go from amber to green in about 50 seconds. Okay. Next thing I'm going to do is I'm going to put some IP addresses on these devices. These are static IP addresses because they're servers. So let's go ahead and do that. 208, 209, excuse me, .88.40.10. This is going to be a /16. I'm going to make this a 0. Be sure to modify the subnet mask. Okay, it's just saying this is the network portion. This is the host portion. Okay, we're going to give it a default gateway, which is going to be the router at 209.88.0.1. Okay, so I've done that. All right, I think we're good on that one. Let's do server 3, which will eventually be our DNS server. We're going to be working with these servers in another lab. Like this, 209.88.50.20, and subnet mask 255.255.0.0/16, and the default gateway 209.88.0.1. I think I've got all that correct. Yes. Let me double check this one here as well. 209.88.0.1 and 209.88.40. Yes, I think we're good to go on both of those. You can see those link lights did eventually turn green. It took about 50 seconds. All right. So let's validate something first. I'm going to get rid of that toolbar, so that bottom toolbar, so we can see a little bit better. Let's verify what PC1 can reach. Now, the only devices PC1 should be able to reach are devices on its own local area network, and any networks that router LAN 1 is directly connected to. So it should be able to reach any of these. If I wand over PC4, I can see it's 10.21.53. So let's see if it can reach that network. Okay. So we can see the IP address, because I did ipconfig earlier, 10.1.53. So just out of sheer randomness here, this happens to have not the same IP address, but on a different network, but the same last number, 10.20.1.53. Is that what that was? Let's see here real quick. 10.21.53. Yep, that's what it was. Okay, let's see if we can ping it here. Now the first ping timed out because the ARP request. We can actually do a trace RT to that same address and see that it goes through our router. You can see that it's going through its default gateway, 10.10.1.1, and then to 10.21.53. Now, this one here, 10.31.50, it's kind of hard to see that address, 10.31.50. So that's the, oh, doesn't have the, I didn't put the address on there. Let's go ahead and do that. Rick didn't do all of his homework. I left these static so we could actually access them, knowing the IP address. So 10.31.50, okay, and that's going to be a /24 mask. Okay, and its default gateway is going to be 10.31.1. All right, so we should be okay there. Let's make sure it can ping its default gateway. You should have done that already in your lab. I'm just now getting to it. Okay, so it can ping its default gateway, its router, because we've already configured that router. But what I want to show is that PC1 cannot reach this device because this router does not know where to send those packets. And even if it did, we haven't configured these two routers to know what to do. Well, this router to know how to get to this network. So let's verify that it cannot reach it. Ping 10.31.50. So we're getting an ICMP message back, destination host unreachable. Okay, so what we want to be able to do here is we want to tell this router how to get to, well, let's take a look at all these here. We want to tell router LAN 1 how to get to any networks beyond the networks that is directly connected to. Basically, it's going to send all those packets to edge. We can tell router LAN 2, besides the networks it's directly connected to, send those packets to edge. We're going to tell edge about the two networks on that's connected to router LAN 1 down here, 10.10.1.0 and 10.21.0. And we're going to tell edge about these two networks over here, 10.30.1.0 and 10.41.0. We're also going to tell edge about how to forward packets that are not within our little enterprise network here, our little company network, and to forward those to the internet service provider, the ISP. So let's get started with this. And so what I'm going to do is, let me make this a little, there we go. So we can see exactly what we're working on here. I'm going to get rid of that. Get rid of that. And we are going to, let's take a look at router LAN 1. Well, I'll tell you what, let's start here at edge. Okay. So on edge, what I'm going to do, get a little bigger, is I'm going to tell it how to reach 10.10.1.0 and 10.20.1.0. So I'm going to do static routes. And this is actually, for those in my introduction to networking class, we do this in much more detail in my other classes. Okay, IP route. This is a static route. This says configure. This is a static route, meaning send packets for, let's put the network 10, 10, 1.0, 255, 255, 255.0. So sent to this remote network. So any packets to that remote network, send them to the next hop router, 10.1.1.2. That's all we needed to do for that. That's like one post office saying, if I have any letters going to these addresses, send them to this post office. Now we're going to do the same thing for the 10.21.0 network. So I'm just going to do an up arrow here, and I'm just going to change that to a 20. Okay. Now, while we're here, move this over a little bit. There we go. Let's take care of these two networks on edge. So same thing. We're gonna tell edge for anything in the 10.30.1.0 network, send them, but those are going to go to a different post office, a different router at 10.1.1.6 is the next hop. So I'll type this one in from scratch. I'm blank line there so you can see the difference. IP route 10.30, I need a space there, 10.30.1.0, 255, 255, 255.0. But if I get packets for anything in this network, I'm going to send the next hop router 10.1.1.6. Then it's that router's responsibility. Okay. And the same thing for the 10.40 network. So we're just going to change this to a 40. Okay. So what about routes out here? Okay. We're going to do a special static route. This is called a default static route. Right now, for this edge gets any packets for any of these networks here that we see here. It knows what to do with them. It knows what to do 10.10.1.0, 10.21.0, send them to 10.1.1.2. For 10.30, 1.0 and 10.40, 1.0, send them to 10.1.1.6. But how about anything else? Well, the internet, many networks, right? Actually, over 1 million summarized networks. Talk about that in later class. But we don't want to put in all the, hundreds, thousands, millions of static routes. We're going to put one static route, and here it is. Just like hosts have a default gateway, meaning, hey, if the packet's not in my network, I send it to this router. Routers have a default route that says if it's not in my network, and we show that as all zeros with a subnet mask all zero, meaning no bits have to match. We'll talk about that in the later class. How this and these determine how many bits must match. Won't go in that here. I'm going to send everything else. If I don't know what to do with it, I'm going to send it to my ISP router at 209.552. There we go. Okay. So that's our edge router, but we're not done yet, are we? Okay. Because what we also need to do is we need to tell router LAN 1, hey, if those packets aren't in my network, what should I do? Well, let's go to router LAN 1. I could do a static route that lists all these networks over here. But why do that? all I need is one default route that says, if I don't know what to do with it, you're the only router, Edge, you're the only router I'm connected to. So I'm going to send all those packets to you. If they're not in my directly connected networks, everything else, I'm going to send them upstream to you. So let's do that on router LAN 1. Config T, IP route. Again, that it can have its own default route. And we're going to send those router LAN 1 says I'm going to send those to 10.1.1.1. If I don't know what to do with it, it's yours. Okay. Now we're going to do the same thing on router LAN 2. It says, hey, if I don't know what to do with it, I'm going to do the same thing. If I don't know what to do with it, I'm going to send them to you. Because you seem to know about these networks, you know about my networks, and you have a default route of your own. Okay, and we talk about this in great detail in my other classes. So let's do our AT IP route. And we're going to send router LAN 2 says, I'm going to send those to 10.1.1.5, my next hop router, and next hop post office. Did I do that right? Yes. We're almost done. We've done all of our networks. So, matter of fact, we can do a little testing here. Let's go back here and have, remember when we had, let me make that a little wider here. Remember when we had PC1 trying to reach this PC over here? Let me give ourselves a little bit more. There we go. PC1 trying to reach PC at 10.31.50. It couldn't before. But now, if we look at these routing tables, I did an end, show IP route. Again, later classes, I talk about this in more detail. Here's the static route, static default route saying, if it's not in my network, I'm sending them to 10.1.1.1. Let's look at Edge. Edge will get the packet. Let's do an end here, show IP route. It has several static routes. It says, oh, you're trying to send a packet to 10.31.50. I'm going to send those to 10.1.1.6. This is the entry in the routing table. Talk more about this later, another class, but this is the remote network. And this is where I send it next, the next hop router, next hop post office. The S means I learned it statically. So 10.1.1.6, that means we can send it down here. And this router here says, oh, yes, I'm directly connected to that. Show you. Yes, I'm directly connected to that network. So I can send those packets right out this interface to this PC here. And packets coming back, when they go back to PC1 on the 10.10.1.0 network, when router LAN 2 gets packets going back the other way to PC1, it says, oh, well, if I don't know what to do with it, I send them to Edge 10.1.1.5. That was the static default route that we did. Okay, and then Edge will say, oh, I have packets for 10.10.1.0. What do I do with that? Oh, I have a static route that says I send those packets to 10.1.1.2. And then LAN 1 gets it and says, oh, I belong to 10.10.1.0 network. Send it out my gigabit 0.0 interface. It's like a series of post offices that know what to do with each other. Okay, that know what to do with packages and letters it receives for other neighborhoods. Let's just test this real quick. Before we were not able to ping 10.31.50. Let's give it another try. You might have some ARP timeouts here, which you normally wouldn't experience in a network, and then it works. And matter of fact, here's the cool thing. Let's do that trace route again. Let's do a trace route to, what was that? Trace route to 10. 131.50. Let's see where the packets go to get there. Ah, look at this. So we can see packets first one to 10.10.10.11, its default gateway, and then 10.1.1.1, router LAN 1 sent them to 10.1.1.1, and then Edge sent them to 10.1.1.6, and then router LAN 2, move this over, sent it to the destination. Pretty cool, huh? All right, we have one more we need to do. ISP. So let's configure the ISP router. The ISP, we're going to do this. Similar. Okay. What ISP says, you know, all your networks over here, they all belong to the 10 network. So I could list them individually: 10.1.1.1, 10.10.1.1, 10.10.1.0, 10.20.1.0, 10.10.30, but no, they all begin with 10. We're going to pretend, we talk more about this in later class, but we're going to pretend that our company owns the entire 10 network. So what it's going to do is this. We're going to put a static route. The ISP is going to have a static route that says anything IP route going to the 10 network. That whole 10 network belongs to you. So I don't care what it is, but as long as the first 8 bits is a 10, I'm going to send these packets to you, and you deal with them, Edge. So it's going to send them to 209.5.5.1. Okay. All right. So it says anything to 10 network, you're going to handle it, Edge. All right. Let's just, yeah, I think we're about ready to go here. I think we're about done. As long as Rick didn't make any mistakes. Make sure I have my static default route going back here. That looks good. Okay, so let me make this a little smaller. Okay, so any of these devices now, any of these devices should be able to reach each other and these servers here. Okay, let's give this a shot. Let's have PC1. What was our server? 10 or 10? 209. Let me do this here. Let me bring PC1 up so we can see this more easily. Excuse me 1 second here. There we go. So we're going to have PC1, see if it can ping our web server. Ping, not Pong, ping 209.88.40.10. Might be some ARP stuff happening. There we go. Yes. So now we can reach the internet. This is our pseudo internet. Matter of fact, let's do that trace route. We always like watching that, right? Well, those packets, let's here. Those packets went. So we can see that those packets, here we can see everything now. Okay, so those packets went from PC1 to its default gateway, 10.10.1.1, 10.10.1.1 right here. Then to 10.1.1.1 right here. And then to 209.552 right here. And then to our server that's over there someplace. There it is. All right. Don't forget to save your running configs. Copy running to start, or let's show the whole thing. I can do the autocomplete. There, router LAN 1. Get rid of that. How about edge? Copy, run, start. I can just do copy, run, start. That shortens it. Same thing here. Copy, run, start. And copy, run, start. And then we can just save our packet tracer file. Rick's going to save his. There we go. And we are done. Okay. The next lab that we'll be doing is actually configuring this web server and DNS server. And then we are all but done. Okay. All right. Hope this lab helped. Thanks for watching.